Next question. MCQ with one or more than one correct options. We have which of the following statements is are correct. We need to choose how many of the statements given is are correct. Sulfite thiosulfate can be differentiated using dilute HCl solution. So when we go for sulfite ion and thiosulfate ion and allow it to react with the dilute acid like HCl, this gives colorless gas of sulfur dioxide with pungent smell that can turn acidified dichromate solution green. And when we take this thiosulfate and allow it to react with the dilute HCl, can't we get SO2? We do get SO2, and this SO2 once again remains colorless, burning sulfur smell, turns acidified dichromate green. But along with this, the yellow or white turbidity of sulfur is formed, which is not there in this case. So there is a difference. Only sulfur dioxide gas is formed, and here along with the sulfur dioxide, the yellow white turbidity can be seen at the bottom of the test tube. Therefore, one can be differentiated from the other by using dilute HCl. Hence, option A is correct. Both nitrite and nitrate dilute solutions gave brown ring test. This is also correct. And soluble sulfides react with sodium nitroprusside solution to give purple coloration. This is also right. Aluminum salts give blue ash test while zinc salts give green ash test. Even this is one of the confirmatory tests for aluminum and zinc respectively, therefore correct. So the answers are A, B, C, D. And we have discussed in detail the answer for A. Then what about B? Both nitrite and nitrate dilute solutions give brown ring test. Nitrite ion, the dilute solution of which is taken, to which freshly prepared ferrous sulfate is added, and then dilute sulfuric acid is sufficient here rather than concentrated, and hence brown ring is formed. So in aqueous solution we can even write the composition of the brown ring as FeH2O5NO, and this substance is responsible for brown coloration that will be formed as a ring at the junction of acid and aqueous layer. So the substance is responsible for brown ring. So the test is positive. And similarly, when you take nitrate also, we have the similar test. Large excess freshly prepared ferrous sulfate is added, and now concentrated sulfuric acid drop by drop along the walls of the test tube is added without disturbing the test tube, so that a brown ring is formed at the junction of acid and aqueous layer. So both nitrite and nitrate give brown ring test, but in the case of nitrate, dilute sulfuric acid is sufficient enough, while in the case of concentrated, sulfuric acid is required in the case of nitrate ion. And when you go for the option C, soluble sulfides react with sodium nitroprusside solution. For C, soluble sulfides, that is sulfide in solution. Let us take an example of Na2S. To this, when we add sodium nitroprusside solution, Na2FeCN5NO, when this solution is added, sodium nitroprusside, purple coloration is developed due to the formation of addition compound Na4FeCN5NOS, and this substance is responsible for that purple coloration, and it is one of the confirmatory tests for sulfide ion in solution. So therefore it is right. And when we see the option D, what we have, aluminum salts give blue ash test while zinc salts give green ash test. So for this D also, aluminum salts like aluminum sulfate, which give aluminum oxide during the reaction, say Al2O3, that is formed with the aluminum salt during the reaction, combines with cobalt oxide that can be formed during heating as cobalt nitrate is added. The cobalt nitrate breaks down to give cobalt oxide, nitrogen dioxide and oxygen. So these two combine to form CO, that is cobalt, AlO2 taken twice. Cobalt meta-aluminate is formed, and this substance is responsible for blue color, and thereby the ash gets blue color on performing the test and is called blue ash test, which is confirmatory test for aluminum salt. Similarly, for zinc salts, which on heating can give zinc oxide, and the cobalt nitrate which is added become cobalt oxide on heating to give cobalt zincate, COZnO2. And this cobalt zincate is the substance which is responsible for green color and is called Rinmann's green. Thus, for zinc salts, we generally carry out the green ash test, and for aluminium salts, we carry out the blue ash test. Thus, D is also right.